Hi, this is Dina Lane from Halls Middle School. This is our KCS Summer at Home edition on the Pythagorean Theorem. Today we're going to be explaining the Pythagorean Theorem and its converse. We're going to apply it, and then we're also going to use it to find the distance between 2 points in a system. Okay, today we're going to be talking about the Pythagorean Theorem. The Pythagorean Theorem revolves around a right triangle. A right triangle is a triangle that contains one right angle. The two sides of the triangle that make up the right angle are what we call our legs. We use the letters A and the variable B for the legs. Either leg can be A or B. The long side, the side directly across from the right angle, is what we call the hypotenuse. The variable that we use for that is C. Here we're going to illustrate the Pythagorean Theorem. If you notice, I have my right triangle on the inside, and what I've done is I've taken each of the legs and the hypotenuse and I've extended them to a square on each of the sides. The first thing I'm going to do is I'm going to look at this red square. We're going to talk about the area inside the square. The side length of my leg was 3, so the area, or the amount on the inside of the square, would be 3 times 3, or 3 squared. I could simply count the red squares if I wanted to, and that would give me an area of 9. In my green square, this leg has a side length of 4, so that means it's 4 by 4. 4 times 4 is 16. My blue square has a side length of 5, so the area on the inside of that would be 5 times 5, or 5 squared, which is 25. Now, I want you to look at these 3 numbers and see if we can mathematically connect those 3 numbers. 9 plus 16. If I take 9 plus 16, that's going to give me 25. And what that means is if I come over here to this and I take the red squares and the green squares, they're going to fit perfectly inside of the blue squares. And that is what is called the Pythagorean Theorem. Now let me show you what that means algebraically. Here's my right triangle without the squares on the sides. We could label the legs A and B. And remember, it doesn't matter which leg is A and which leg is B. The hypotenuse is what we call C. Now when we found our areas of the squares, we took the side times the side. So that means it was A times A, or A squared. That 9 represented that red square, which was A squared. We added to that our side B, the square off of it, B squared, and together those two made up C squared. Okay, we have 2 more examples of our Pythagorean Theorem. In this first right triangle, we are given A and B. Now, I'm going to try to go away from drawing the squares, but I'm still going to picture them. My theorem is A squared plus B squared equals C squared. My A is 9, so I'm going to do 9 squared. So if I draw the square out here, what would the area of that square be? It would be 81. My B is 12, so I'm going to substitute 12 in for B. Think about if I drew that square out. 12 times 12 is 144. And we don't know our C yet. That's our goal. That's what we're trying to find. So we're going to add these 2 together. And when I add these 2 together, that's going to give me 225. So that means this big square over here has an area of 225. I don't want to know C squared. I want to know just plain C. So I'm going to take the square root of both sides, and that gives me C equals 15. So my C here is 15. In the next example. Now this one's a little different. This time they're giving me one side and the hypotenuse. So I'm given A and I'm given B, but I am given A and I'm giving C, but I'm missing b. Now let's think about this for a minute. The a squared plus the b squared gave me the c squared. So how could I find the b length then? We're going to do the inverse. Instead of a squared plus b squared giving me c squared, I'm going to take my c squared and I'm going to subtract my a squared from it, and that's going to give me my b squared. So my c is 26, and again, if I think about my square right here, that means I'm going to do 26 times 26. That's going to give me 676. So this big square has 676 minus my a squared, so that's 10 times 10, so a squared would be 100. And I'm still looking for my b squared. So what would the area be of this big square here? Remember, if the two littles fit inside the big, to find the little one, I'm going to take the big square minus the little square. So 676 minus 100 gives me 576. But I just want b, so I'm going to take the square root of both sides. And you can use your calculator to help you with this. The square root of 576 is 24. So this side length is 24. So in your Pythagorean theorem, a squared plus b squared equals c squared. Or you can take your hypotenuse squared, c, and subtract one of the leg squares out and come out with the missing leg. What the Pythagorean theorem is, we're going to use its converse to prove if a triangle is a right triangle. If we know we have a right triangle, we can use a squared plus b squared equals c squared. The converse of that means if a squared plus b squared equals c squared, then you have a right triangle. So we're going to use that to determine, is this a right triangle? So this would be my a, this would be my b, and if it was a right triangle, this would be the right angle, so this would be c. And remember, your c is always your largest side. It's always the longest side. So to prove, we're going to try our Pythagorean theorem. Our a I have labeled as 5, so we're going to do 5 squared. Our b is labeled as 12, and our c is labeled as 13, so I'm just substituting everything in. So 5 squared is 25. That means my square right here would be 25 units. My b squared would be 144, and my c squared, 13 squared, would be 169. Now we're going to add these two together. That gives me 169. Since these two small ones, the two legs squared, adds up to be the same as the hypotenuse, this is a right triangle. Let's try another example. Sometimes they don't always give you a picture. They just give you your units of measure. So on this one, you have to figure out which one is the longest side to determine which one is C. 12.2 is the longest, so that's C. Now remember, A and B doesn't matter, so this is going to be my A, and this is going to be my B. So now let's come over here and let's see if this works. If it's a right triangle, A squared plus B squared would give me C squared. My A is 6.4, so I'm going to square that. My B is 12, and my C is 12.2. I'm going to use my calculator. 6.4 squared gives me 40.96. 12 squared, I don't need a calculator, that's 144. And 12.2 squared gives me 148.84. Now let's add these two together to see if the two squares fit inside that one larger square. When I add those two together, I get 184.96. That is not equal to 148.84. So therefore, this is not a right triangle. This is our third type of Pythagorean theorem problem we're going to be discussing. This time, we were given coordinates and we plotted them to make our right triangle. Once they're plotted on a graph, it's very simple to count your side lengths for your A. 1, 2, 3, 4. So this side is 4. My B side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now my C side I cannot count because it's not going horizontally or vertically. So that's when I have to use my Pythagorean theorem. So if we remember, A squared plus B squared equals C squared. My A was 4, so 4 squared plus my B is 10. And that's going to give me my C squared. 4 squared is 16. 10 squared is 100. Now when I add those together, I get 116 equals C squared. Now, I don't know the square root of 116, so I'm going to use my calculator. When I do that, I get a big long decimal. So I'm going to round my decimal to the tens place. So this 7 tells us 7 to go up. So this side length would be about 10.8 units. Now, what if this wasn't drawn out for us? What if we didn't have graph paper? Is there another way to get our 4 and our 10? Our side 4, if you notice the y value here, this is talking about, and if you take it back to your slopes, to your rise, my y value up here is 6. On this bottom level, it's 4. So to figure out how far apart those are, you could do 6. I'm sorry, it's 2 here. I was reading that 4. I apologize. The y value here is 6. The y value here is 2. So I could do 6 minus 2, and that's going to give me my 4. So I'm doing my y values, and I'm subtracting them. y2 minus y1. For this distance, I'm going to subtract my x values. 13 minus 3. And that's how I come up with my 10. This is what we call the distance formula, and you'll kind of become more acquainted with that in high school. Here's what it looks like. I'm going to take my y2 minus my y1, and I'm going to square it. That's where I get 4 squared, which is 16, just like I did down here. Plus 13 minus 3, and I'm going to square that answer. 13 minus 3 is 10. 10 squared is 100. Now we're adding those two together, just like we did down there at the bottom. 100 plus 16 is 116. And then I'm going to take the square root of 116, which still comes out to be 10.8.
Okay, let's see if you can figure out what the scarecrow's error is.
Where I come from, we have universities. Where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D.
Ph.D.?
That's Doctor of Thinkology.
Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, joy! Rapture! I've got a brain!